In this lesson, I'll show you how to find the Laplace transform of a function. This is question number 2. The question reads, find the Laplace transform of y is equal to f as a function of time is equal to sine at. The first thing that I'll do is set this up using the following, where I have the Laplace transform of our function, which is sine at, is equal to the integral between 0 and infinity for our function sine at times e to the power of negative st dt. What's been provided for us is the following integral, and if this wasn't provided for us, this would be a very complicated function to integrate. So luckily it has been provided, and the only difference is that ours is negative st, and this is in terms of au and bu. That's not a big problem. In fact, if we follow the following, we should end up with the answer quite easily. So we have sine at is equal to, I'll just rewrite this as e to the power of negative st over ab. Now be careful here. Our a is the b here. So this gets replaced with a squared. Notice that this is supposed to be b, but it's a. And over here we have au, but in our case it's negative s. So we have negative s to the power of 2 plus a to the power of 2 bracket. A once again is negative s sine at minus what we had for b, which is a cosine bu at. Now instead of putting this constant c, we don't need to do that because this is being integrated between 0 and infinity. But we can't use infinity because it's an improper integral and it won't make sense. So instead of infinity, I'll use another letter. Let's call that letter w, and 0, our lower bound. Let's start by taking the limit of this equation where t approaches w. And remember, w is equal to infinity. So if I place a very large number into here, it will become negative a very large number. And e to the power of a very large negative number is equal to 0. So if this is equal to 0, then this factor is equal to 0, and everything's equal to 0 if we take the limit as t approaches w. So that part's done. Now we will subtract by what we get when we evaluate this at 0. So if I place 0 into here, I end up with e to the power of negative s times 0. E to the power of 0 is equal to 1. So we end up with 1 over negative s to the power of 2 is s squared plus a squared. And if I place 0 into here, sine at 0 is equal to 0. So this goes to 0. And cosine at 0 is equal to 1. So this becomes negative a, because this would become 1, and negative a times 1 is negative a. If I multiply this out, and by the way, I'll scratch this out so you don't get confused. If I multiply this out, I'll end up with positive a over s squared plus a squared, and this represents our frequency function, which I'll call f at s. And there you have it. That is how to find the Laplace transform of a function.